Now let us continue with probability SAQs from Maths 2A. So the next question is A and B are events with P of A is equal to 0.5, P of B is equal to 0.4 and P of A intersection B is equal to 0.3. Find the probability that first bit is A does not occur, second bit is neither A nor B occurs. So first let us write A and B are two events. And also what is given to us? Given that P of A is equal to 0.5, P of B is equal to 0.4, P of A intersection B is equal to 0.3. First bit is we need to find out the probability that A does not occur. A does not occur means P of A bar we need to find out. P of A bar is 1 minus P of A. That is 1 minus 0.5, which is equal to 0.5. Now the second bit is we need to find the probability that neither A nor B occurs. So probability that neither A nor B occurs. I already told you or means union. So nor means P of A union B whole complement. Okay. So that is 1 minus P of A union B. But we don't know what is A union B. We know P of A, we know P of B, we know P of A intersection B. So we will use addition theorem here. 1 minus in the place of P of A union B, we will write P of A plus P of B minus P of A intersection B. So that is 1 minus, what is P of A? 0.5 plus P of B is 0.4 minus P of A intersection B is 0.3. So 1 minus 0.5 plus 0.4 is 0.9. 0.9 minus 0.3. That is 1 minus 0.6. 1 minus 0.6 is 0.4. Now take the next question. State and prove multiplication theorem of probability. Very, very important question. So let us put the side heading first. Multiplication theorem of probability. Or theorem of compound probability. This is also called as theorem of compound probability. Now let us see what is the statement of multiplication theorem. Let A comma B be two events in a sample space S such that P of A is not equal to 0. P of B is not equal to 0, then number 1, P of A intersection B is equal to P of A into P of B by A. We read this as P of B given A. This is conditional probability. Number 2, P of A intersection B is P of B into P of A given B. This is the statement of multiplication theorem. Now we will start the proof. Let n of A be the number of sample points in A. N of B be the number of sample points in B. N of A intersection B be the number of sample points in A intersection B, and N of S be the number of sample points in S. Then how can we write P of A? P of A is number of favorable outcomes by total number of outcomes. So that is N of A by N of S. P of B can be written as N of B by N of S. P of A intersection B can be written as N of A intersection B by N of S. Now how can we write P of B by A? That is, we have a formula for conditional probability. N of A intersection B by N of A. Then how can we write P of A by B? That is N of A intersection B by N of B. So after knowing everything, let us first take the first bit. We'll take the LHS first. Okay, so what is the LHS? P of A intersection B. This can be written as N of A intersection B by N of S. Now what I am doing is multiplying and dividing by N of A. So here we are multiplying and dividing by N of A into N of A intersection B by N of S. Now we are rearranging the terms. We are writing N of A by N of S into N of A intersection B by N of A. N of A by N of S is the formula for P of A, and N of A intersection B by N of A is the formula for P of B by A. Hence proved. This is the first bit. Now the same way we will take the second bit. Second bit is LHS is P of A intersection B. Same way, P of A intersection B can be written as N of A intersection B by N of S. Now here we are multiplying and dividing by N of B. In the first bit we multiplied and divided by N of A. Here we are multiplying and dividing by N of B. Now we are rearranging the terms. We are writing N of B by N of S into N of A intersection B by N of B. So this is P of B and this is P of A by B. Second bit is also proved. Isn't it easy? Now take this question. This is very, very important. Recently appeared in TS March 25 paper and AP March 24 paper. So the question is, A speaks truth in 75% of the cases and B in 80% of the cases. What is the probability that their statements about an incident do not match? So what does it mean? A speaks truth in, suppose there are 100 cases, in 75 cases A speaks truth, and in 80 cases B speaks truth out of 100. So what is the probability that their statements do not match, which means if A speaks truth, B should not speak the truth. If B speaks truth, A should not speak the truth. So what is the probability of that situation it is asking. So now you see, let A be the event that A speaks truth about an incident. So what is the probability? What is P of A? 75 by 100. 25 threes are 25 fours are. So that is 3 by 4. Now what is P of A complement? P of A complement is 1 minus P of A. That is 1 minus 3 by 4 is 1 by 4. Now the same way, let B be the event that B speaks truth. about an incident. So P of B is equal to 80 by 100. That is 4 by 5. So if P of B is 4 by 5, then P of B complement will be 1 by 5, no? 1 minus 4 by 5 is 1 by 5. So we have P of A, P of B, P of A complement, P of B complement. But their statements do not match. That is the question. So probability that their statements about an incident do not match is P of, if A speaks truth, B should tell lies. And if A does not speak truth, B should speak truth. So if you have A, then you should have B complement. And when you are having A complement, you should have B. So because the events are independent, you can write it as P of A into P of B complement plus P of A complement into P of B. Why? Since A and B are independent. Because they are two different persons. One does not affect the other. Now we have all the values. What is P of A? 3 by 4. P of B complement? 1 by 5. P of A complement? 1 by 4. P of B? 4 by 5. So that is 3 by 20 plus 4 by 20. That is 7 by 20. This is the answer. Now take this question. This is very, very important. Recently appeared in TS March 24, AP May 23, and TS May 22. So the question is, a problem in calculus is given to two students, A and B, whose chances of solving it are 1 by 3 and 1 by 4 respectively. Find the probability of the problem being solved if both of them try independently. So let's see how do we proceed. Let A be the event that the problem is solved by A, which means P of A is equal to 1 by 3. Let B be the event that the problem is solved by B, which means P of B is equal to 1 by 4. Now, how if find the probability of the problem being solved means when is the problem solved? If either A solves it or B solves it. Yes or no? So the probability of the problem being solved. So if either A solves it or B solves it, the problem is said to be solved, right? So I already told you, or either or means union, both means intersection. So what do we have to take here? We need to find out P of A union B. We use addition theorem here. P of A plus P of B minus P of A intersection B. But because it is an independent event, A and B are independent events, right? So we can write P of A intersection B as P of A into P of B. P of A into P of B. Why? Since A and B are independent. We have P of A value, P of B value. So 1 by 3 plus 1 by 4 minus 1 by 3 into 1 by 4. So that is 1 by 3 plus 1 by 4 minus 1 by 12. Take LCM. LCM of 3, 4 and 12 is 12. In 3 table, 12 goes 4 times. So 1 4s are 4. In 4 table, how many times 12 goes? 4 3s are 12. So 1 3s are 3. And in 12 table, 12 will go one time. So 1 ones are 1. 4 plus 3 is 7. 7 minus 1 is 6. So that is equal to 6 by 2, which is equal 6 by 12, that is equal to 1 by 2. Understood? So 1 by 2 is the final answer.